Very much. I feel very honored to be here. I'm honored that I was invited to come and speak here. This is exactly the kind of gathering I like to address, because really we've got to bridge this gap between academia and the practical world. You know, in the academic world, we get off in our little ivory tower and we have to do replicated scientific trials, which are not necessarily what growers need. We need to take the principles that we might be looking at and trying to understand in the world of academia and translate them into practical, real-world applications. How do you take the principles and actually use them to reduce your costs, to reduce all the problems and the difficulties, the lack of fertility? How do you use that information to get rid of the pests and the diseases? How do you keep water in your soil? How do you keep nutrients in your soil so we don't lose any of those materials downstream? We harm nobody downstream from your farm. We should hold all those nutrients, all that water on farm. Because if you lose them, then you're going to have to replace them. So how do we take the principles of what we've been finding out about with the soil food web and apply them to the practical world? So this morning's talk is really to introduce you into the principles with a few bits and pieces of practical applications sneaking in there. But you have to understand the principles first. What makes soil productive? And principles that work no matter where you are on this planet. And I suspect I will be shocking a number of people as I relate the discoveries that we've made over the last 45 years that I've been working out there in the real world. So bridging that gap. Yes, I do have the academic alphabet soup after my name. Woohoo! So undergraduate, master's, PhD, I've postdoced. I am currently the president of Soil Food Web, a company I started after I ran smack into my university's, Oregon State University's, absolute dedication to Monsanto. So, not my favorite people, Monsanto. There was supposed to be a pointer up here someplace. I don't see it. So anyway, if you need to get hold of me, there it is, soilfoodweb@aol.com. I can't promise you that I'm going to answer immediately. I get on average about 300 emails a day. And I have help answering all those emails, so we will hopefully get back to you. If we don't respond, send the email again, because it's probably been buried. So a little bit of my background. I think you can probably read this better than I can read it myself. So my undergraduate degree, I am a Minnesota girl, and every once in a while you can hear the accent in my voice when I talk. Good Scandinavians in that part of the world, and so very that Scandinavian lilt to that accent. Went from St. Olaf College to Texas A&M, so suddenly discovered that not everybody had to deal with 12 feet of snow in the wintertime, and I've never gone back as a result. Winter in Minnesota? Oh, no, no, no. So from Colorado State, from Texas A&M, where I worked in marine microbiology, where I started discovering some of the principles applied to aquatic systems, and then moved into soil at Colorado State University, postdoc there, where we really figured out why do we have all these species of bacteria in the soil, and they're different every place you go on the planet. If the ecosystem is different, we have a whole set of different species of bacteria and fungi. Fungi are not just bad guys. I've always been amazed that people say, well, fungi just cause disease. Really? Is that true? Apparently those people who say that can't read, because they could not possibly ask that question if they had come and listened to a talk like this, for example. What do protozoa do in your soil? Do you need them? Are they important? What do they do? Well, you're not growing plants without protozoa. Ooh, so you need them. Okay, what's the function? How does that work? And I want to briefly go over these facts. Nematodes. There should be only beneficial nematodes in your soil. If you've got root feeders, Mother Nature is trying to send you a message. You don't have soil, you've got the four-letter D word in the world of soil science, dirt. You have dirt. See, you have to say it with just that kind of disdain, dirt. If you don't have the proper biology, you're not dealing with soil, you're dealing with dirt, and you can't possibly grow the plants that you want to grow if you're dealing with dirt. What's the difference between soil and dirt? Soil requires the presence of the living organisms in your soil. You must have bacteria, fungi, protozoa, nematodes, microarthropods, mycorrhizal fungi, all those cute little creepy crawlies in the soil. Otherwise, you're not going to be able to grow those plants as you want, where you are going to get the maximum benefit. So, understanding the role and function of all of those organisms. Well, what do organisms need in order to stay alive? Think of yourself. What do we have to supply to you 3 times a day, basically, every day that you're alive and living on this planet? You need food. Microorganisms in the soil, they're just like you. Think of yourself as being a rod-shaped bacterium on a much larger scale. That's all we are. We're just like bacteria. If you wouldn't do tillage to yourself, don't till your soil and kill your microorganisms. Don't slice and dice your fungi. Don't destroy this biology that's present in your soil. Every single inorganic fertilizer is going to be killing these organisms in your soil. Every single pesticide kills way more of the beneficial organisms than you do of the disease causers. If you go out and you nuke your soil with a pesticide, you're going to knock down all of the organisms, the bad guys as well as the good guys, but who comes back faster? The bad guys. So what have you set the stage for in your soil? Once you use a pesticide, who's growing? And good luck having a good crop. So we have to reverse that trend. The only reason the Green Revolution worked is because we had already destroyed this biology in our soil and turned our soil into dirt. So how do we reverse that trend? So those are some of the things I'm going to be talking about today. Briefly, to get a little bit more in-depth, all day Thursday I will be talking about more practical approaches to how do we put this biology back into your soil? Where do you get the organisms from? How are you going to manage that? Because probably through no fault of your own, you've perhaps listened to people that told you the only way to grow plants is to kill things. And so now you're going to have to put this biology back into the soil. How do you nurture it? How do you keep it present? And of course, when we think about that definition of soil, we've got to have organisms, we've got to have organic matter to grow those organisms, and we have to have the sand, the silt, the clay, the rocks, the pebbles, the parent material. That's the true definition of soil as defined by the father of soil science, Hans Jenny. And unless you have all of those components, it's not soil, it's dirt. So, understanding those principles, let's go through a nice little framework. I think John has put these slides on the internet, so you can go and download them. So I think that's available. If you haven't discovered where they are, talk to John. And I have to say that without John Medley's time and effort getting me here, I wouldn't be here today, because it's been a little bit of a challenge to deal with all of the work to get the schedule set up right. So taking a look at the soil food web. And please realize that before 1986, most scientists had no idea that all of these organisms were important and that they had a role in making sure your plant stayed healthy. So when we're looking at, I wish the pointer. Oh, I gotta do, I can't see that. Oops. Pointer? It suddenly appeared. It was a snake, it would have bit me. Oh my. Can you see the little red, can you see the red dot? Oh, because I can't. So sunlight, photosynthesis, plants make sugar. Most of the sugars from photosynthesis are translated down into the root system. So over 50% of the energy of any plant we care about is going to be translocated down into the root system and stays in the root system or the soil. Your plant is putting out exudates into that soil, food to feed the organisms. Isn't that a wonderful scientific term? Exudates. What does that mean? What's an exudate? See, this, scientists, we like to invent language so that only other scientists in my specialty area of expertise know what I'm talking about. So that you have to come and hire me to explain what's going on. Money drives the world. Isn't it wonderful? So what's an exudate? So an exudate is basically made of mostly sugar, a little bit of protein, and a little bit of carbohydrate. Ooh, great. That didn't help much, did it? If I asked you to go into your kitchen and make a recipe of mostly sugar, a little bit of protein, and a little bit of carbohydrate, how many different kinds of foods am I asking you to make? Okay, so what's sugar in your kitchen? White sugar, brown sugar, honey, molasses, syrup. So anyone or all, or what's the mixture and percentages of those different kinds of sugars? So take your bowl and start putting that mix in there. What's protein in your kitchen? Well, milk, eggs, maybe a little cheese. So think of the combinations, all the different kinds of mixes of sugars and proteins. And then, of course, what's carbohydrate in your kitchen? Flour. So we're going to put a lot of sugar, a little bit of protein, eggs, milk, and a little bit of flour. What is that a recipe for? Cakes and cookies. Your plant is dumping cakes and cookies out into the soil in order to feed these microorganisms. So where do we find most of the bacteria and most of the fungi? And if you follow the little arrows here, those exudates coming out into the soil are going to feed bacteria, and they're going to feed fungi. So the highest concentration, the most species diversity of bacteria and fungi exist in the soil around the roots of your plants. Now, are those plants going to be putting out exudates that feed the bad guys, that feed the diseases and the pests and the problem organisms? Well, if your plant put out foods that fed the bad guys, what's going to happen to your plant? It's dead. It's gone. End of evolutionary story. No seeds made. So these exudates are strictly things that are going to grow the beneficial bacteria and fungi in that soil. And so most of the bacteria and fungi around those root systems, they're building castle walls to protect your roots against diseases and pests and problem organisms. Most of the time, your bad guy organisms won't even know your roots are there. But you have to have all of those bacterial species and fungal species present in your soil. So when the root grows through, putting out the exudates, contacting those organisms, they will start to multiply and grow and completely protect your plant from any disease and pest. If you no longer have any diseases or pests attacking the root systems of your plants, do you need pesticides? Is this going to save you money? Exactly. Let's get these beneficial organisms mixed back into our soil. Where are you going to find this massive diversity of the indigenous bacteria and fungi that your plants require to protect their root systems? Where are you going to find them? You're going to grow your own compost, because that organic matter that you put into your compost pile contains all of the species of local organisms. You put that organic matter into that pile and you compost correctly, and you're going to end up in 21 days, if you do it right, 21 days, you now have an inoculum of all the best bacteria and fungi and protozoa and nematodes for you to go back and put all these organisms back into your soil. So it's not a difficult process. This is not going to cost you a massive amount of money. You don't have to be putting on massive amounts of compost. People always make the mistake where they try to calculate what's the nitrogen, what's the phosphorus, what's the sulfur present in the compost, as if the compost is a fertilizer. It's not. It's an inoculum of the organisms you need to put back into your soil. So if you're doing it right, you should only have to apply compost once. And then you maintain those organisms in your soil growing around the root systems of your plants. Decomposing the dead plant material at harvest. So that dead plant material decomposes within 1 month of that organic matter hitting the surface of your soil. So how long ago did you harvest? And do you still have detritus? Do you still have that organic matter sitting on the surface of your soil? Mother Nature is trying to send you a message. You do not have the biology in your soil. You're going to have diseases, you're going to have pests, you're going to have nutritional problems, you're not building structure, your root systems are unhappy, your plants are unhealthy. We need to look at these simple ways to tell whether you have the life you need or not. And if you don't, grow some compost. So, exudates coming out of those roots, feeding the bacteria, feeding the fungi, and only the beneficials will be fed. So now we have a massive amount of bacteria and fungi around the root system of that plant. Now, these bacteria and fungi are going to do something more than just protect your roots from disease. Bacteria make a lot of glues. If we're talking about aerobic bacteria, and of course, they have to be aerobic. They better not be anaerobic. The anaerobic organisms are the disease causers. They are the bad guys. The anaerobic organisms are going to drop the pH of your soil down below 5.5, and that is going to harm your plants. There is no way to get a soil pH below 5.5 as long as you maintain aerobic conditions. So here's a critical principle. If we're going to grow healthy plants, it has to be aerobic, because there's really nasty things happen. As soon as we go anaerobic, we're growing diseases, we're dropping the pH low, you're losing most of your nitrogen, your phosphorus, and your sulfur as gases. Only under anaerobic conditions do we convert our soluble, inorganic forms of nitrogen, phosphorus, or sulfur into gases, and they leave your soil. How many of you can grow good plants if all your nitrogen, your soluble inorganic nitrogen, which is the only kind your plant takes up, what if it's all gone? It's left the system as a gas. How many plants are you going to grow? What is the yield going to be like if you've allowed your soil to become compacted? So we have to have the bacteria with the glues that they make build microaggregates in your soil. They pull those small-sized particles together and start to build a safe, protected place for them to live. Whereas that soil solution comes by, those bacteria are going to be grabbing the soluble, inorganic, everything out of that soil solution, and they hold and keep the nutrients in your soil. We should never have nutrients leaving our soil and ending up in our surface waters. You put an inorganic fertilizer out on your soil, what happens to 80% of that inorganic fertilizer once it's applied? Goodbye. It's leaving the system. It does not stay in your soil. Why do we have to keep putting on higher and higher, more and more amounts of inorganic fertilizer as time passes? Because we've destroyed more and more of the biology. There is no way for you to hold those nutrients in your soil. You are damaging everything downstream when you're using inorganic fertilizers. Oh, but that's the only way to grow plants. Oh, really? Gotta really question that particular point of view. And we're gonna go through those arguments here in just a few minutes after we finish this. So bacteria building microaggregates, building structure in your soil. We then have to have the fungi. Fungi grow as these long strands. And the fungi are going to take the microaggregates, the little particles made by the bacteria, and pull them all together into macroaggregates that you can see with your eyeballs. When you take your hand, put it in your soil, pick up that soil and give it a shake, you should be able to see the hallways and the passageways built by the fungi using the microaggregates that the bacteria made. And then water will move and infiltrate into your soil as deep as that structure has been built. In a normal soil, where we have normal sets of microorganisms, how far down into the soil does water infiltrate if you've got good, healthy soil as deep as you possibly can go? What's the depth? 16 miles. If a compaction zone has happened anywhere along the way, the water moving through is going to hang up at that interface. Water will not continue to move, and that water puddling at that depth is going to go downhill and take all your soil with it. So erosion is only a consequence of the damage that we've done to the life in the soil. Get that biology back into your soil, and you won't have those problems anymore. Hold and keep your nutrients where they belong, where they will become available to your plants in the future. So we want to be growing those bacteria and those fungi, building structure that you can see with your own eyes. If you want a little advance notice of whether you're going to have this structure built, get a little microscope. Costs you $350. Go to my website, order one. It comes with a camera. Take the online microscope course, and you learn how to use that microscope in 24 hours. Now you can start assessing your own soil, your own compost. It's not difficult, it's not hard, and you don't have to be sending those samples into the soil chemistry lab anymore. You look at your own biology. So great, structure, holding and building soil, retaining our nutrients. But you know what? There's a problem here. Because that set of nutrients tied up in the bacteria and fungi is not available to your plant. If you've got really good bacterial and fungal growth and that's all you've got in your soil, you're going to kill your plants. Because they are going to take up your nitrogen, phosphorus, sulfur, magnesium, calcium, sodium, potassium, iron, zinc, all the different nutrients your plant requires. It's going to be held and retained in their biomass. So how did Mother Nature fix this problem? What did she do to put together normal nutrient cycling that happens in every ecosystem on this planet? Well, it's the next set of critters. Protozoa eat bacteria. And because the requirement for nitrogen concentration, phosphorus, sulfur, magnesium, calcium, sodium, potassium, the whole list, is way lower in protozoa biomass, when a protozoan eats any bacterial species, it releases nitrogen, phosphorus, sulfur, magnesium, potassium, sodium, iron, zinc, boron, everything you want to talk about, in the proper balances for your plant, is going to be released. Where do most of the bacteria and soil grow? Right around your root zones. So when those bacteria are eaten by their predators, most of the nutrients are going to be released right in the root zone, and your plant says, thank you. That was very kind of you, Mr. Protozoa, to eat those bacteria that I grew with the exudates coming out of my root system. Isn't this amazing that Mother Nature figured this out, and that's how she cycles nutrients? It's so simple. Why do we have to make it so complex? Let me calculate for you exactly how much nitrate your plant is going to take up. Yeah, that's kind of esoteric and alchemic, isn't it? Listening to a fertilizer guy trying to explain that to you. Woo! When we're talking about fungi, immobilizing nutrients, fungi are eaten by fungal-feeding nematodes and by fungal-feeding microarthropods. Whenever one of these guys eats one of those guys, nutrients are released right at the surface of the root system. Your plant doesn't have to work at all. It's got all the nutrients it needs. So let's make certain we get these organisms back into your soil. If we're holding and retaining every nutrient you require in the bacteria and fungi, and then when the time is right, the protozoa, the nematodes, the microarthropods eat the bacteria and the fungi and release the nutrients so that every second of every day that your plant is growing, It's going to get the balance of all the nutrients it requires. Talk about high nutrition plant material. We typically see increases from typical pasture grasses, maybe only 5 to 6% protein in pasture grass. And by getting this proper biology into the soil, we see increases up to 25 to 26% protein. Think that's going to grow a few better cows? Think you're going to be making a little more milk of higher quality? Human beings eating that food. We're getting the nutrition that we require. You don't need to be taking vitamins, supplements. What is wrong with people? That they think that supplements are the way to get healthy again. Food is medicine, and you need to be getting the nutrients that you require in the food that you eat. How do you make certain that those nutrients are going to be in your food? You must have the organisms in your soil. So hopefully now you've got a really good idea why you need bacteria and fungi, why you need protozoa and nematodes, the fungal and the bacterial feeders, why you need microarthropods. Would it be possible that you can get too many of these organisms and they overeat your bacteria and fungi? Absolutely. You get too many predators, now how are you going to fix this? Well, how did Mother Nature fix it? Go look and see how nature figured out this conundrum. Well, yeah, it's the next set of predators in the system. How do you keep these guys in balance? You got to have somebody else that eats them and keeps them in the proper balance so the nutrient cycling can go. So we've got to have predatory nematodes. We have to have macroarthropods, the bigger guys that eat this trophic level. Well, and then how do you keep these guys in balance? Then you got to have birds, you've got to have earthworms, you've got to have spiders, you have to have voles and shrews and mice, and who is the top of this food web? We are. We are the gardeners of this planet. That is our charge as human beings. It's not to extract, it's not to destroy. It's to maintain natural interactions so that we don't destroy our society. We have to go back to this. We have no choice. If human beings are going to remain on this planet, we have to stop destroying it. So if we want to stick around, we better pay attention and shift to this. It is completely sustainable. It doesn't cost the grower anything more than planting seeds in the springtime and then going out at harvest and harvesting the yield. Pests, diseases, lack of fertility doesn't exist if you get the biology correct in your soil. You don't have to work that much. So put back into your soil your willing organic workers so you don't have to work so hard. If you're out there working really hard and having to work and get rid of the weeds and hoeing and pulling and squishing pest bodies on the leaves of your plants, take a note. Mother Nature's trying to send you a message. Please learn how to read this so that you don't have to be doing that work anymore. Put these guys back to work for you, both in the root system and above ground. Top part of your plant is really not that different from the root system of your plant. So get the biology back into the system. Because remember, Mother Nature doesn't need human beings, but we need Mother Nature. It's a one-way street. She can do perfectly fine without human beings on this planet. I mean, after all, think of dinosaurs. They must have annoyed Mother Nature a lot. And look at what happened. So a summary of all these benefits that are obtainable by getting the proper biology back into the soil. So suppressing disease, the right bacteria and fungi in the proper balances, and we'll talk about those balances in a minute. So you don't have to use pesticides. When we're going to work with you one-on-one to figure out what are your problem organisms, what are the difficulties you have, is it pests, is it diseases, is it weeds, is it a lack of fertility, is it puddling on the surface of your soil, is it compaction? We're going to come up with specific recommendations, exactly what you need to do to shift your soil in the right direction. There are laboratories, Soil Food Web has laboratories around the world where you can send samples, but I would much prefer for you to learn how to assay your own soil. It takes one day for you to learn how to use that microscope and identify these organisms so you know what's going on and you can immediately work to fix things. We retain nutrients, so we're not going